The Big Moon Dig has found a great site for a lunar settlement, and it comes with a challenge. Let me tell you just a bit of the story. The Big Moon Dig was founded about 5 years ago with the idea of using 21st century ideas, technologies, and social networks to continue the human exploration of space. We quickly came to the conclusion that only meters-thick layers of lunar regolith had any chance of providing adequate radiation protection for human habitats. The necessary level of protection will take an enormous amount of digging, hence the group name. Early on, we also concluded that writing short stories about what participation in the project would be like was a good way to spread our ideas. As the stories are all set in the first half of the 21st century, they are full of hot technologies like a piece of lunar excavation equipment with an artificial intelligence brain and managed by 3 teams of humans stuck on Earth. So here I am, Digger03, lunar excavator. Moreover, that brings us to one big question: where can we find a good location for a lunar settlement? What then makes a really great lunar settlement site? Are any of the Apollo to the Moon sites great settlement sites? At least we know something about them. Sadly, no. The sites were all chosen for safety in landing and for good science. These are good things and useful, but the Apollo astronauts only stayed 3 days, and could not have survived 5 days at those locations with their equipment. We are looking for something quite different, but what? There are a number of key features that we decided were really needed. First is ease of access from Earth and support for safe landings. Second comes a large construction site with fairly level ground. Third is a line of sight back to Earth to support 24/7, 365 communications. Fourth is direct sunlight for power, as many hours in a lunar day as possible. Fifth is access to volatile materials like water. Let's take them one by one. Ease of access. Apollo 13 got home only because it was still on a free return trajectory. That is, the lunar transfer orbit it was on during the way out would bring it back to Earth without a major expenditure of fuel, called delta V. This is a great feature should something go wrong, but it restricts you to near equatorial lunar sites. If you need a lunar polar site, and you probably do, you first lose your free return trajectory, and then you must provide some extra delta V to achieve the lunar polar orbit. You get less mass delivered to a polar site for any given rocket system. When you get to the Moon, you need a place to land. The landing field must be flat and free of large rocks and holes. This can be harder than you might think, as most of the large flat areas on Earth, the plains and ocean bottoms, were created by water. The Moon has never had such water. All the flat places there slope a little this way and a little that. The landing area should also be a safe distance from the living area but not too far. Construction area. We will need a large area to build our settlement separate from the landing area. The area needs to be flat enough to allow easy layout of building. Most of the flat area on the Moon are rolling with slight random slopes. What we need is large areas, where the slope does not exceed about 15% to allow construction. Line of sight to Earth. The lunar site must have line of sight back to Earth. This allows direct communications at all times. This requirement is met by nearly the entire Earth-facing side of the Moon, but can be a problem near the poles. Solar power. The most valuable power source on the Moon is the Sun. On most of the lunar surface, the sunshine is available for power for 2 weeks on and then 2 weeks off. This would require both serious restrictions on activity and enormous batteries for the night portion. There are, however, a few locations near the lunar poles, where the sun is visible most of the time. These sites are called peaks of eternal light. At these locations, the sun skims the far mountains at midnight without ever vanishing completely. During the day, the sun circles around only a few hands above the horizon. At all times, the sun is low in the sky and the shadows are long. Access to volatile materials. Volatile materials on the Moon, especially water, are very rare. Water is a key material for a settlement and is needed for people and crops. It is also useful for making rocket fuel. Other volatile materials, like helium-3, could even have commercial value. One of the most likely sources of volatile materials on the Moon are the permanently shadowed craters that occur only near the poles. Radiation danger. Nearly every spaceship and space habitat you have ever seen on television or in the movies is a death trap. Radiation has been recently found to be a severe problem that will drive all future designs. Recent space instruments around the Moon and on the way to Mars show that the radiation danger to human flesh is twice as bad as previously thought. Moreover, we were not even handling the old, low estimate adequately. The only material available on the Moon for radiation shielding is the ground-up rock that covers nearly everything, called Regolith. The question is how thick a layer is needed. There are two types of radiation, cosmic rays and solar storms. Any location on the Moon can expect 0 to 5 solar storms a year. This radiation does not penetrate very deeply, but there is a lot of it. The missions that monitor the Sun can give us adequate warning, but operations at the surface must be suspended for a day or two each time, to prevent serious health issues. A spaceship's skin will not stop this form of radiation, but a large tank of water or 1 meter of regolith will. The cosmic rays are far more penetrating. In fact, 1 meter of regolith will only result in secondary radiation, making the problem worse. The Big Moon Dig calculated the mass equivalent of regolith comparable to the atmosphere of Earth to be between 4 and 5 meters. Burying a habitat deep enough for radiation protection demands a lot of digging. The good news is that an inflatable habitat will easily support that much cover material in the Moon's 1/6 gravity. Conventions. There are a number of conventions about space settlement that come out of existing treaties. We should always use the word settlement and never the word colony. The colonial period on Earth was so unfair that there is no justification for extending it into space. There is simply no reason to offend countries that were once colonies, like the United States of America, by the use of a word. The Moon is metric. We have lost too many space missions over blown conversions. We also need the ability to use anybody's old equipment in an emergency and not depend on Apollo 13 kludges. The ground-up rock that covers the Moon is not soil. Soil contains both water and organic materials. Lunar regolith contains neither. A Massif is simply a rock formation that is bigger than one mountain but smaller than a continent. What a great word! Mountains on the Moon are rarely named, because they are hard to see from Earth. The convention is to name a mountain after the nearest large named crater, in this case, crater Scott A. The Scott A Massif is the remnant of a ring of a once mighty basin, the biggest on the Moon, the South Pole-Aitken Basin. This basin is responsible for the peaks of eternal light near the South Pole. The Scott A Massif, the Big Moon Dig's choice, as the best place for a lunar settlement is the Scott A Massif. It is a major rock formation about 120 kilometers from the south pole of the Moon. It runs from 20 to 45 degrees longitude lunar -84.7 to -86.1 latitude lunar. Its key properties are large size. The city of Los Angeles could easily fit on the construction area of the site. Peak of eternal light. The south face of the Massif is a peak of eternal light that has solar power available all through the long lunar night. Permanently shadowed craters. There are at least 3 possible trails down to permanently shadowed craters. There is simply no better place on the Moon for a settlement. Flyby. In this flyby of the Scott A Massif, green is good and suitable for transit by a wheeled vehicle and possibly for construction. Blue is useless for construction, but might be traveled over with a specialized vehicle with great care. Red is just plain dangerous, a slide to oblivion and death. The flyby starts from the south, over the pole, and swings to the east, moving up the eastern trail. It then crosses the face of the Scott A Massif over the peak of eternal light area. It then swings to the west and backs down the western trails. The flyby then ends back where it started. Peak of eternal light photo. This striking image, taken by the Japanese Kaguya satellite, shows the view coming over the southern lunar pole moving toward the Earth-facing side of the Moon at a time very near to lunar midnight. The brightly lit patches are peaks of eternal light, and the best of these is the southern slope of the A Massif. The challenge: the Big Moon Dig assembled the flyby above from the first 2 years of Lunar Reconnaissance Orbiter LRO altitude data. This mission now has years of new data available. Also, at the 2-year mark, the data had been reduced only enough that students could work with it using personal computers applying Excel and SketchUp. The work was, however, difficult. Now far more data is available, and it is available in forms that a student can work. In addition to the altitude data, detailed photographic data can now be laid over the surfaces. In short, it is time to rework this data set and develop definitive answers to serious questions. The Big Moon Dig would now like to put forth a challenge for serious students of the Moon to complete the work we started and determine if the A Massif really is a great place for a lunar settlement. This work will require 3 stages. 1. Remap the A Massif using all available data. 2. Identify the best solar power sites. 3. Map the trails down. These tasks are a challenge for any student, but a serious student should be able to make good progress. Mapping: now more LRO data is available, and has been analyzed in more detail. Precision photographic work, which was then only available in the form of long strips, is now available knitted into maps. It is time to redo this work, and then study the site in much more detail. The first stage of our challenge then is to remap the A Massif site using all the LRO altitude data, with the local slopes, and the photographic data too. Space enthusiasts will also want files of the site that can be 3D printed. Solar sites: the next task of our challenge is to analyze the specific areas of the A Massif that qualify as a peak of eternal light. The sites must receive useful sunlight around midnight, full sunlight at local noon, and be flat enough to allow construction. At the poles, you place your solar panels on a vertical billboard with a central pivot that you spin around once a month. How tall does that pivot need to be? Trailblazing: the next step is to map the trails down off the Massif leading to the permanently shadowed craters. These trails must have slopes below about 20 degrees. Remember, all the surfaces are covered with powdered rock that provides little traction. The 2-year data suggested that there are 3 such trails, 1 to the east and 2 to the west. Will this finding hold up with more data and better analysis? Exactly how long is each trail? They appear to be tens of kilometers long. For only portions of the lunar month will solar power be available on those trails, and then only in limited areas. Map where solar power is available along each trail. Conclusion: if you want to get yourself into space in your lifetime, better get started now. The old ways of human space exploration, like Apollo to the Moon, are no more. New ways, 21st century ways, are just coming into view. If there is interest, we will raise some money for a reward purse for the A Massif challenge, and produce more videos and short stories in this series working out how a 21st century human space program could work. This series will include the key concept of why we should do space at all. We can find this new path to space together. Thanks for your attention. Please visit our website. You can Google The Big Moon Dig for our contact information and free stories about believable characters, like me, Digger03, and dedicated action on many problems of climate change, including 21st century approaches to human space exploration. Let us know if you are interested in participating in a proper contest about the A Massif. Please subscribe to see more videos in this series. Thank you, Digger03 and Tom Riley. The Big Moon Dig.